Hello my class 10 students. This is the sample paper 3 of ICSE Physics Class 10 Semester 2 exam. It is a prelim paper of one of the reputed ICSE schools. In this video, I shall be solving question 1 and question 3 only. But you could also solve the entire paper for practice to get full marks. Pause the video, write the answers and check it with my solutions, okay? I have been teaching physics, chemistry, maths for 41 plus years. So watch the video till the end, and if you find this helpful, consider subscribing to my channel and also check out the links in the description. So shall we solve the paper? As you know, section A is question 1, which is of 10 marks. And these are all MCQs. Let's look at question 1. Resonance occurs when? Now, when does the resonance occur? When the frequency of the externally applied periodic force is not greater, not less than or equal to, but when it is equal to. So, first answer is D. The second one, the latent heat of melting is the amount of heat required to raise the temperature? No, because this is latent heat. So we can't. The amount of heat required to raise the temperature? Again, no, temperature will remain constant. So not this. The amount of heat required to change the unit mass of substance from solid to liquid? Yes, but it will have to be at a constant temperature. Let us see D. The amount of heat required to change the unit mass of a substance from solid to liquid at a constant temperature? Yes, so this is the correct one. Let us come to the third one. Two resistors connected in series to give an equivalent resistance of 10 ohm. When connected in parallel, they become 2.4 ohms. And the individual resistances will be, now I know this is 6 and 4, but let us see how we write it. Okay, so here we have the first answer was D. Second answer also is D. Third answer. So let us look at our third answer. We will call the two resistors as X and Y. Okay. This is our rough working we will show here. So we will have X plus Y is equal to 10. So Y will be equal to 10 minus X. Now 1 upon Rp is equal to 1 upon X plus 1 upon Y, and Rp is 2.4, so 1 upon 2.4 is equal to 1 upon X plus 1 upon 10 minus X. Okay, so I'll call this as 10 upon 24, and that is equal to here X into 10 minus X. So it will be 10 minus X plus X. So this 10 and this 10 gets cancelled. So 24 is equal to 10x minus x squared. So you'll have x squared minus 10x plus 24 equal to 0. That will give us x minus 6 and x minus 4 equal to 0. So you will have x equal to 6 or x equal to 4. So if x is equal to 6, your y will be equal to 10 minus 6, that is 4. So it will be here 6 ohm and 4 ohm. Okay, then we come to the fourth one. The diagram shows a free conductor AB is kept in a magnetic field and is carrying current from B to A. So the direction of the current is like so, which is into the plane of the paper. To avoid the confusion, complete path of the circuit is not shown and direction of the force experienced by the conductor will be. Now if it's direction of the force, then you have to use the Fleming's left hand rule. Okay, so take out your left hand and first show the field. So you will have the field that is 4 finger like this. So now the center finger will be inwards. This is the center finger, which is representing the current, and the remaining folded finger will be like this. This will go like this, and your thumb will be like this. I hope you got this. This part is not there. Okay, so this is your thumb. So we have the field along this north south, Then we have the current, which is into the plane of the paper here, and then the thumb will be like this. It is along this direction. Can you see that? And so the motion of the conductor will be down. That is option B. Okay. The fifth question, 3, 4, 5, 6 joules of heat is produced in a conductor of resistance 30 ohm where the current is passing through it for 3 minutes and the current flowing will be, and these are the choices. So let's check it out. So we write the heat, that is 3, 4, 5, 6 is equal to I square RT, and then 3, 4, 5, 6 will be equal to I square into R is 30 into time is 3 minutes into 60 seconds. So our I square will be equal to 3, 4, 5, 6 upon 30 into 3 into 60. 3 goes tens, 3 ones, 3 ones, 3 fives and 3 twos. 3 ones and here 3 threes, 3 eights and 3 fours. And 6 tens and here 6 will go 6 times 36 and that will give us our I equal to under root 64 upon 100, which is going to be 8 upon 10, which will be 0.8. Now where is the 0.8 option? 0.8 option is A. Let's come to our sixth subpart. An alpha particle consists of 2 electrons, 2 protons. It does not have electrons. 2 electrons, 2 neutrons, again no. 2 protons, 2 neutrons, yes. 1 electron, no. So the correct option is C. 7th subpart. The diagram shows a magnet moved near the coil along its axis. Which of the diagram shows the correct flow of current during this motion? Now south pole is coming away from this. So to attract the magnet, it will be north polarity generated at the near end, which means it will have anti-clockwise current. Anti-clockwise current means it should go like this. So it's going to go from under and over like so. So which one of these is matching? This one, B. So let us write it. Let's come to 8th subpart. The radiation having maximum ionization power is alpha, so that will be A. 9th one, when beta particle is emitted from the nucleus of the radioactive atom, the mass number decreases. No, mass number remains the same. So this will be the only one which says mass number remains the same is this one. Let's check. Atomic number increases by 1. Yes, this is correct. Here again they are saying mass number decreases, so that is not correct. So this is A, this is C. And find the heat energy required to raise the temperature of 20 grams of copper from 45 degrees to 52 degrees. So that is delta T, 7 degrees C. And SHC of copper is given as 0.42 joule per gram per Kelvin. So let us just show this working and let's check this. This I have worked it out. It is 58.8. So it's option C. But let us see how we write it down. Okay. So 8 was option A. 9th was option C. And 10th one, as I told you, option C, which is 58.8. But let us show the working here. We will have Q equal to MC delta T. And the mass was 20 gram. SHC was 0.42 and delta T was 7. So we'll have this getting cancelled. And 84 into 7 upon 10. Let's multiply. 7 4s 28, carry 2, 7 8 56 and 2, 58 upon 10, 58.8 joules. Okay, so that finishes our section A. Okay, so as you can see how we have written the options so that it's easier for the examiner to look at your solutions and give you the marks. And you're working wherever it's required, you just show it here so that you can double check at the same time. I'm going to solve question 3 now. Let's look at question 3. Name the radiation which is negative in charge coming from the nucleus. Now you know that negative charge will be the beta radiation. So it's going to be beta. Having highest penetrating power is going to be gamma because they are electromagnetic in nature. doesn't affect the mass number and the atomic number when emitted. Again, this is gamma. And then we have this circuit diagram. Let us write 3A. So we written 3A answers. First one was beta, second gamma, third one also gamma, and that should give us our 3 full marks. Let us come to 3B. 3B is a circuit diagram like so. So we'll have to show this in rough, and then we have to find the current flowing through the circuit. That will be for 1 mark. Potential difference across 8 ohm, that will be 1 mark, and the voltage drop will be the third one, that will be again for 1 mark. So 3, 6, 8. Let us see how we draw the diagram. So I've drawn this diagram, and we have to find the current in circuit. So for that we need the resistance. So we'll say 3 ohm and 6 ohm are in parallel. Therefore 1 upon Rp will be equal to 1 upon 3 plus 1 upon 6. That will give us here. So therefore our Rp is going to be equal to 2 ohm. Now we have the current in the circuit is going to be E upon R plus R because there is internal resistance here. Okay, EMF is going to be a 6 volt, and the total resistance external will be this Rp plus this. So that will be 2 plus 8 and plus the internal resistance, that is 2. It's going to be these many ohms. So that will give us 6 volt upon 8 into 10 into 12 ohm. That is going to give you half, means 0.5 ampere. Remember, the answers in physics paper have to be in decimal. So this is going to be our answer 1. Our second part will be PD across 8 ohm, and that will be let us say is V1 is equal to IR1, and that is according to Ohm's law. And so the current in the circuit is 0.5, means half, multiplied by R1 means this 8. So that will give us 4 volts, and that is our answer 2. Drop in potential. So we have drop in potential will be actually E minus V, which is equal to IR. We know this formula. So we are using this. I means 0.5 means half. And internal resistance, you can see this 2 ohm. So that will be equal to 1 volt. And that is our answer 3. So marks wise, you get this 1 mark, you get this 1 mark, you get this 1 mark, and that's how you'll get your 3 marks. Now we come to 3C. We have been given this diagram of the electromagnet, and I want you to see over here that the current is going this way and it is going in this first arm in a clockwise way. It's going this way like so. So this is your clockwise when you look from here. Okay, so A becomes south, B becomes north. Write the law or rule concerned. Now what did we look over here? We looked at the anti-clockwise and clockwise direction here. That means we have used the clock rule. So we have to write the rule, not state the rule. Make a distinction between state the rule and write the rule. Write the rule means you just write it down. And 2 ways to increase the strength of the magnetic field. You know what the answer will be. You can add 1 more cell to the circuit in series, or you can decrease the resistance of the rheostat to increase the current, and you can also increase the number of turns in the arms here of the electromagnet. So we write the first answer, A south polarity, B north polarity, and that will give us together 1 mark. Name the rule. So we will say it will be the clock rule, which states that, so we have, if the current is anti-clockwise, then it will be north polarity, and if it is clockwise, then south polarity. So the strength of the electromagnet can be increased by increasing the number of turns in the coil and by increasing the number of current in the circuit. So we have this one giving us 1 mark. This one giving us 1 mark and this one giving us 1 mark. So this C part was for 4 marks. So that is how we are having 20 marks of 2 questions that I have solved. You can solve all the other questions if and when you want for your extra practice. But I'm going to end the video over here. I hope you have understood the way of presenting your work. You understood how to write your answers, how to think on the spot, and you also know how the marks will be distributed for you. Okay, so study well for your SEM 2 examination. All the best. Bye.